Hello ladies, so once again to recap what we are doing, we are looking at nomenclature, that is how to name compounds, and more exactly we are focusing on binary compounds, so how to name oxides, peroxides, hydrides, and even some acids and solids because the system is the same, rules are the same, so we are checking also some of them. So we have covered already type 1 compounds in which the element in the compound is a metal and it has only one oxidation state. So we are looking there at all the elements from group 1, 2, 3 and some transition metals. So in here, type 2, which is the one that I'm going to explain in this video, will include all the metals that have two or more oxidation states. So that's the key difference. In here, the elements have only one oxidation state. In here, it has two or more. And remember that this metal is always the first element appearing in the formula. For example, if I have something like this, copper and oxygen. So this element coming first, is the metal, which is also called the cation. So that's the element that I'm going to focus on. Because for the second one, this is going to give me the functional groups of oxide, peroxide, hydride, and in that case, I am only looking at one oxidation state. So I don't really need to check the oxidation state of this one. I only focus in the oxidation state of the first element of my cation. Okay, so that's how it works. So let's have a look at how type 2 works. The only difference, as I said, the oxidation states. So we have to use Roman numbers in order to indicate what is the oxidation state, which one is the oxidation state of my compound. So these are some steps written in words. If you want to work with words, this is how it is described step by step. And so first one is exactly the same, the first step that we did for type 1. Identify which one is my cation, which one is my anion. So this is the first element. This one is the second element in the formula. This one is going to be the positive oxidation state. This one is going to be the negative oxidation state. So either way you can identify it. If you identify oxidation states, the positive is the one that goes first, and it is the cation. And then second step, name the cation and write in brackets the oxidation state. So this is the step that changes in this type 2 compound. First step, exactly the same. Second step, we have to add the oxidation state. And then step 3, if you notice, is exactly the same that we did in type 1 compound. So it's going to be a little bit easier to get this one because steps are very, very similar. Okay, so let's have a look at some examples to clarify what we are saying here in these steps. So, for example, we have these 4 compounds. So I will need to check my periodic table for the name of that first element. Pb is lead or lead. This is the element. And this compound has a O2. Okay, so it might be an oxide or it might be a peroxide. So I first have to decide which one I am going to name or what kind of compound is this one, because that will determine the ending of my name, because that will determine the name of the cation. So I already know that Pb is going to be my cation because it's the first element that appears in my formula. If I check the oxidation states of this element in the periodic table, it actually contains +2 and +4. So if you remember, the rule in peroxides is if I have a compound with this general formula of element O2, as this is the case, element O2, and it turns out that the element has oxidation state +4, this compound is going to be an oxide. Okay, so this compound is an oxide. So knowing that, I know that my anion, if I am going to name the anion in this case, is oxide. Well, it's oxygen, oxygen with a -2 of oxidation state. So in this case, my compound is an oxide because of the oxidation state of the elements involved. So if I'm going to name the compound, then it's going to be the name of the element. In this case, it's lead. And I have already determined that this is an oxide, therefore the oxidation state is -2, therefore the oxidation state of lead is +4. So this is the number and this is the step that we have to do for this particular type of compounds. 4, so I need to write number 4 in Roman numbers because that's the oxidation state of lead. So lead, name of the element, oxidation state of the element, and then the anion. In this case, the anion is oxygen and the ending "ite" for oxide. Okay, so that's the particular step, adding the Roman numbers. So that's what is different and that's what is going to help me to identify what is the oxidation state and what type of compound is that one. In this one, easy way to identify if it's an oxide or a peroxide, it has a 3. So if the subscript is different to 2, straight away, that's going to be oxide. So again, I look for the name of this element, first element, which is chromium. So it's going to be chromium. I hope the spelling is right. Oxide, but once again, I have to determine oxidation states because I have to write the oxidation state of chromium. So oxygen is -2 because I have determined that it's an oxide. Therefore, chromium is going to be +3 in order to balance this out to 0. Or if you do crisscross backwards, this 3 goes here, these two goes here. Okay, so chromium number 3 because that's the oxidation state of chromium, and then the word oxide again. That's how it works. And then in here, you can try yourself and do these other 2 exercises. Looking here, we have a parenthesis, and the parenthesis is holding the peroxide ion, meaning this is going to be a peroxide. So I'm helping you there already to determine. And in this one, again, as we did in exercise number 2, different to 2, that's going to be an oxide. Okay, so try and do it yourself. The only step changing from type 1 to type 2 is this one. This is the key. Roman numbers showing oxidation state of the first element. And that's it. That's the only difference with type 1. Let me know if you have any questions.